Hello everybody, it's Mr. Do the Math here, and today we're going to talk about radical expression. A radical is a term for the nth root. Radical is an nth root, right? Write this down so you can put it in your notes, right? And the square root is what it's known as, right? The notation for the nth root is this. So you got bop, n, r. N being the index. N represents the index. And this represents the radicand. Right? That represents the radicand. Right? The nth root is the inverse of the nth power. Right? Nth root is the inverse of the nth power. Right? So when I take the square root of something, the opposite of taking the square root of it is squaring it, raising it to the second power. Right? And so if, like I just said, if a is to the nth power, if a to the nth power equals b, then the nth root of b equals a. Right? So here's your example. If we got 5 squared equals 25, n being 2 and b equals 25, right? So it'd be the square root of 25 equals 5, right? Like that. If I had the 7th root, right? So it'd be, 7 to the 3rd power equals 343. Then the 3rd root of 343 equals 7, right? And then 2 to the 9th power equaling 512. Then the 9th root of 512 equals 2, right? So that's how we're rocking. All right, now, simplifying the rule for absolute value. If the an absolute value is needed around a variable when you simplify the radical, when the pattern of the index is even and the power is even on the inside. Your answer is going to be an odd root or odd degree, right? So for instance, if I had the square root of x to the 10th power, right? The root is 2. The power on the inside is even as 10. So then the solution would be x to the 5th, the absolute value of x to the 5th. So anytime that you're taking an even root of an even power, and it is perfect where it completely works, then the answer is going to be an absolute value bar. So we're going to look at some examples now. All right, so let's look at simplifying radical expressions, right? So we had the square root of 486, right? The way that you simplify radical expressions is you do prime factorization. You make a factor tree, right? And so we're just going to play with this factor tree in its simplest form. Seeing that this is even, we can divide everything by 2 off the jump, right? So when we divide that by 2, we're going to end up with 243, right? And then when we divide 243, look at 43, it ends in a 3, so we can't divide it by 2, so let's go and see what 3 is. When we divide 243 by 3, we end up with 81 here. Now, this is the 2nd degree, so what we're looking for are perfect squares. 81 is a perfect square, that's 9 times 9, right? And so when you do prime factorization, or simplifying radicals, when you simplify radicals depending on this power, depending on its nth root, that tells you how many pairs you need, right? Or how many groups you need. So I only need 2 groups of the same number, and that's this one. So you're gonna pull a 9 on the outside, and since there are no pairs of 2s and no pairs of 3s, they stay inside. So it'll be 2 times 3, which is 6. So your answer is gonna be 9 times the square root of 6, okay? For some of you guys, this might be a review. For others, this might be seeing it for the first time, all right? Let's look at this next example. This next example says 7 times the 3rd root of 40, right? Now, when you have the 3rd root, we're looking for 3 groups of a number, right? 3 groups of a number. So you need the numbers to repeat 3 times. All right. First things first. Let's break this 40 down. 40 is we can do 2 times 20, right? 20 is 2 times 10. 10 is 2 times 5, right? And now we got all the prime numbers. We have 3 2s. Therefore, we can pull those 2's on the outside of this radical. So we have 7 because 7 was there already. And then we'll say times 2 times the square root of whatever's left, which is 5. So I mean times the cube root of whatever's left. So your answer then will be 14 times the cube root of 5, right? All right. Now, what if we got some numbers and some variables? The same math applies, all right? Except there's something else that's very, very special that happens. And let's talk about it. So if we had this problem here where the 4th root of 1,875, a to the 12th, b to the 15th, c to the 9th, d to the 10th, right? All this is under radicals, right? The other thing is, so the nth root is the same as, so this is, let me see, we got the square root of 25, it's the same as 25 to the 1/2 power, right? So what also happens is, you can, if you have powers inside the radical, you can divide every power by whatever the radical is, whatever the root is, right? So first things first, let's deal with this number. This ends in 5, right? So we're gonna divide everything by 5. When you divide 875 by 5, let's look at my notes, I get 375. Ends in 5 again. We divide that by 5, we end up with 75. When we divide 75 by 5, we get 5 and 15. When we do 15 by 5, we get 5 and 3, right? Again, this is a 4th root, which means I need 4 groups of a number. 1, 2, 3, 4. So I got 4 groups of 5, so 5 goes on the outside, right? So we're done with the number, and the 3 stays inside the radical, right? Now, let's look at our numbers, our variables with powers, right? It's the 4th degree, it's a 4th root, so we're gonna divide every one of these by 4. So that's gonna be a to the 12th over 4, right? Now that's even. Remember that, remember our notes? Where is it at? Where is she at? Right here, right? So the nth root is even, the power is even, and it cancels, it divides out. So 12 divided by 4 is 3, I'm sorry. So then the answer would be an absolute value for this one, okay? Let's rock with the B. So it's 15 divided by 4, right? There's gonna be 3 out of those, right? So you can pull a 3 out of this, and you end up with 2 over 4. So 15 over 4, we have 3. So this 3 goes on the outside, so the whole number, so it'll be b to the 3rd, and that 2 stays inside. And then let's look at that c. C, 9 over 4, right? There's 2 4s in 9, and you're left with 1, you got 1 left over, right? And then d, so 2's gonna go on the outside, I'm sorry. So that's what? C squared. And then we got this d to the 10th over 4. Again, we could pull 2 out of there, and we're gonna be left with 2, right? Because 4 times 2 is 8, and we got 2 left over. So that'll be d squared, right? And now, this 1 stays, this 2, 1 and this 2 stays inside, and this 3 stays inside. So it's gonna be 5 times the absolute value of a to the 3rd times b to the 3rd, b to the 3rd, c squared, d squared, 3, because he didn't have 3 more pairs, b squared, c to the 1st, d squared. So this is our solution. All right, that's the answer for that one. All right, now let's look at this example here. you're seeing every different scenario with radicals. Now in this situation, we have a polynomial function inside of here. Alright, so you have the square root of f squared minus 12f plus 36, right? So again, you got this trinomial here, and it looks like that might be we might be able to factor. So the first thing you want to do is factor what's underneath. That's all we've been doing. When you have radicals and you're simplifying radicals, you're factoring. So in this case, because it's a trinomial, we're going to factor it by multiply, add. So we're going to find the multiples of 36 that add to give you negative 12, right? Those multiples are going to be negative 6 and negative 6. So underneath this radical, you're going to have f minus 6 times f minus 6, which can be simplified to be f minus 6 squared. Let me just write it the same way I wrote all my other f's. F minus 6 squared. Now, again, it's even. It's an even root, even power. Even root, even power. That means that the solution has to be an absolute value bar. So it's going to be the absolute value of f minus 6 is your solution. Okay? All right. And so right here is just simply simplifying radical expressions. Right? In the next video, we're going to talk about the product property of radicals and rationalizing of radicals. Let's just keep going. All right, let me see where we at. All right. We don't have to change. We don't have to cut this out. Let's keep it moving. Let's keep it moving. So we understand this part. Now, product. When you hear the term product, product means to multiply. Product means to multiply. So what we're doing is we're multiplying radical expressions together, right? So for any situation where you have n to the a, the square root, the nth root of a times the nth root of b, the answer is going to be the nth root of a times b. So you multiply them together, right? Even if the n is even, and even if the n is even, a and b must be they must be positive or an imaginary number will occur. So these gotta be like they gotta be positive. All right, so let's rock with them. Let's work them out. So we got 2 times the square root of 21 times negative 5 times the square root of 28. All right, so there's two things that happen when you multiply. You're gonna multiply the coefficient of the numbers on the outside together. So it'll be 2 times negative 5. And then the other thing you're doing is, this is a and b, this is a and b. You're gonna multiply 21 and 28 together. But because we're in the radical, what you really wanna do is you wanna look for perfect squares. You wanna look for things that you can pull from both of these numbers. So what you wanna do is, the first move you wanna do is you wanna factorize. You wanna factorize. Well, that'd be the second move, because the first move is you're gonna multiply. You're gonna multiply all your numbers together, primarily the numbers on the outside of the radical. Then you're gonna factorize to see if you got pairs. 21 is 7 and 3. 28 is 7 and 4, and 4 is 2 and 2, right? This is the second degree, so second root, so we're looking for pairs, right? We're looking for pairs. There's a pair of 7s, there's a pair of 2s. That means that these 7s and these 2s, 7 and 2 gonna go on the outside of the radical. So here, first things first, we multiply. That's 2 times negative 5. It's gonna give you a negative 10. And then you got this 7 that we pulled out and this 2 that we pulled out. So it'll be 2 times 7. And then in the radical, you put in whatever's left, and 3 is left, lowly 3. So we simplify this and we're done. So it'll be 10 times 14, negative 10 times 14, which is going to give us our negative 40 times the square root of 3. That's it, simplified, right? Now, what if we got variables? The same thing happens. Now, when you multiply variables, you add the exponents. That's the main thing. And then we have to take into consideration what their root is, right? So let's look at this example here. it says the cube root of 5x squared y z to the 5th times the cube root of 10xy to the 7th z squared. Okay? First things first, we're gonna multiply everything, multiply these numbers, right? So it's 5 and 10, that's 50, right? And then with our variables, you got x times x squared times x. You're gonna add these together. Whenever you got a variable and no number, it's understood that there's a 1 there. So that's gonna be 2 plus 1, which is gonna give you x to the 3rd. You got 1 plus 7, which is gonna give you y to the 8th, and 5 plus 2, which is z to the 7th, right? Okay. Now, the next thing we want to do is we want to factor them. 50 won't give you 3 pairs of anything, right? But we can look at this x to the 3rd and divide it by 3 and see what happens. It's 1, right? So this can come out, right? So you have a x on the outside. Then we got y to the 8th divided by 3. That's going to give us 2 and 2/3. So we're going to pull out a y squared, and this 2 stays there. And then we got z to the 7th divided by 3, right? That's going to give you 2 and 1/3. So this 2 comes out. So it'll be z squared, right? And then what's inside, you have this 50 y squared z, right? So your answer is x y squared z squared times the square root of, or the cube root, my mistake, cube root of 50 y squared z, right? Now, notice that when I pulled this one out, I didn't put it in absolute value bars. That's because the root was not even and that degree was not even, right? So it just comes out flat out, just like that, flat out. All right. Now, our last part is rationalizing. When we rationalize, we have to get rid of the denominator of the fraction, right? We got to get rid of the radical in the denominator is what I meant when we rationalize, right? So there's some magic that has to happen, right? So let's look at this example here. We got 16 over 24, right? First thing you want to do is try to reduce or simplify, right? Reduce or simplify. So here, 16 and 24 are multiples of 4. Multiples of 4. So that 16 is going to be 4 at the top, and 24 is going to be 6 at the bottom, right? Now, when you have this, the next, well, we can simplify it again. Safety, all right? That's going to be 2 and 3, right? Now, once you have your fraction like this, you can break up the radical. So it'll be square root of 2 over the square root of 3. Now we can rationalize. Rationalize means we got to get rid of this radical. When we do that, we have to multiply the top and the bottom by the denominator, right? So we end up with a square root of 6 over the square root of 9. All right. When you do this, this cancels in. This becomes a perfect square. So it'll be the square root of 6 over 3, right? And that is our answer. Let's look at another example. Here. Let's look at this one where we have a cube root, right? So now we got the cube root of 4 over 5, right? With the cube root, remember we gotta, in order for these things to become a whole number, you gotta have 3 pairs of that. So this is, if we rewrite it as a fraction, it'd be the cube root of 4 over the cube root of 5, right? So to rationalize this one, we need 2 more 5s. So we're gonna take the cube root of 25 because we need 3 of these. 25 is 5 times 5, so you got 1, 2, 3, 5s, right? And then whatever we do at the bottom, we gotta do at the top. So that's gonna be the cube root of 100 over the cube root of 125, which is also 5. So it'll be cube root of 100 over 5, right? What's up?
What's up?
You got 1 more minute.
You
All right. No, you're fine. then let's look at this last example, number 10. Number 10. All right. So we got the square root of 18 over the square root of 6. All right. First things first. Let's see if we can reduce this. Right. So let's write it together. 18 over 6. 18 and 6 can be simplified. 18 can be divided by 6 to give you 3. So you're left with the square root of 3. And there is no bottom number now. And so you're done. Right? So we multiply, we simplify radicals, we multiply radical expressions, and then we rationalize. Rationalize meaning we got rid of the radical in the denominator. All right? So if you have any more questions, don't forget to comment below. And if you haven't already, don't forget to like and subscribe. Until next time, Mr. Do the Math out.